Hey everybody, it's Mr. Carr again. Today we're talking about 12.9 day 2, dealing a little bit more with our inverse trig functions. Okay, so now we get to use this idea. We're kind of doing inverse trig here, but then regular trig there. It's finding the exact value is our goal here. So the thing to remember about this is we're still going to model it on our coordinate grid. We're going to still draw our reference triangles, but the first thing I want to focus on is the inverse cosine here. Okay, so kind of like we did in the previous video, we draw it out on a coordinate grid. Cosine is negative in the second quadrant. So I'm going to draw my -4/7 in that spot. So remember with cosine of theta is equal to x/r. So I can treat x as 4 and r as 7. So it looks like this. Draw a little bit accurate, I guess. We got 4 is in the x direction, 7 is my radius officially. Okay, so that's the idea, is that we're drawing it right there. Now I have my right triangle. I want to find the tangent of that. Well, this is the theta that I'm looking at here. Okay. The tangent is opposite over adjacent, or we can also say that tangent of theta is y over x. So the thing I'm missing here is the y value. So I'm missing this piece right here. So we're going to start with our Pythagorean theorem. So we can do 4 squared plus y squared equals 7 squared. We have 16 plus y squared is equal to 49. Subtract that over. Get y squared is equal to 33. And then I square root that, I get just 33. Just the root of 33. That's my exact value there. Okay, so that means for my tangent of the inverse cosine, -4/7, that's going to come out to the y over the x. So in this case, it's going to be the square root of 33 divided by the x value, which was 4. Okay, so checking your answer with your calculator is just a matter of typing it all in. So I'll start with the inverse cosine of -4/7. Okay, so inverse cosine of -4/7 gets me 124.85 degrees, which you can see is about where that is. It's pretty close to where I drew that, I would say. But then I need to take the tangent of that. So make sure when you do your tangent, you're using not your rounded off decimal number. Use what's in the calculator. So you just arrow up and you hit enter on that. And I totally forgot one more thing, so I have to fix my previous answer. I'm going to take the tangent of 124.85. That comes out to a -1.4. And I just go 3/6. Why is it negative? Totally forgot that only sine is positive in the second quadrant. Tangent is negative. And officially, since I'm doing this is a -4 direction, I should have left this as a -4 here. So my answer here is an overall negative square root of 33 over 4. That's what I should have done originally. So my bad on that one for not mentioning that. But just to double check on my calculator, I could take the negative square root of 33 divided by 4. And I get the same value as this right here. Okay. So again, this is my exact that I used through this process. This is my approximate from my graphing calculator. Okay. That is our main idea today. So we're going to be using our inverses along with our regular trig to find these exact values. Okay. Same thing on this one. Arctangent of -3/4. So again, the goal is, where is tangent negative? Okay. So tangent is negative in the fourth quadrant. So I'm going to draw my inverse, or I'm going to draw my triangle in that spot. So with tangent, remember tangent of theta is equal to, that was y, y over x. Okay, so that means the tangent of theta, this is -3/4. I'm going to go be opposite over hypotenuse, or sorry, opposite over adjacent, my bad. So it'll be something like this, which is roughly right there. Okay, so the y is going to be 3 and the x is going to be 4. Okay, so opposite over adjacent, y over x. So that means I need to find my last value, my hypotenuse here. Okay, or I guess I could say is my radius. So 3 squared plus 4 squared is equal to r squared. So it's a Pythagorean triple. I could just jump right to here. I know its r is 5. So if I want to find the sine of this angle, so the sine of theta there is going to equal to the opposite over hypotenuse. So in this fourth quadrant, only calculus is positive, or only cosine is positive. So that means it should be a negative overall here as well, which I get, it'll be, let's see here, a negative 3 over 5. Okay, so that means that the sine of the arc tangent of negative 3/4 is equal to a negative 3/5. So once again, we plug this in our calculator. So I'm going to do the inverse tangent of negative 3 over 4. Okay, so the inverse tangent of negative 3 over 4 comes out to approximately negative 36.87. Okay, that'll be degrees there. And then I take the sine of that. And that comes out to a negative 0.6, which is the same as my negative 3/5. Okay. All right, we'll do one more example that's like this. So we got inverse sine, the cosine of the inverse sine of negative 1/2. Again, we got negative here, so that puts us in our second quadrant for sine. Sorry, not second, fourth quadrant, my bad. Okay, so that puts us down here. So negative 1 over 2 is going to put me roughly, so here that's, trying to remember, sine theta is equal to y over r. So I'm going to put, yeah, it's close enough right there. 1 and 2 like that. All right, so that means that's my theta. Going to have to find this side here. That's going to be my x direction because cosine is x over r. Okay, so I can do x squared plus 1 squared is equal to 2 squared. X squared plus 1 is equal to 4. Subtract that over, I get x squared equals 3, and then I square root that, and I get root 3. So when I set this up now, special right triangle, if you recognize that as a shortcut, when I do my cosine of that, remember, the fourth quadrant, cosine is positive. So this is actually going to be a positive value now. So if I do the cosine of the inverse sine of negative 1 over 2, that is going to be the adjacent root 3 over a hypotenuse 2 like that, and it will be positive. Okay, so one last check of my calculator. If I take the inverse sine of negative 1 over 2, okay, inverse sine of negative 1 over 2, that comes out to a negative 30. That is my special right triangle. And my last part is take the cosine now of negative 30. And I get a positive root 3 over 2. Or as a decimal number, it comes out to 0.866. Okay, so that's it for our basic versions. Standardized test example, just remember this. If we're dealing with a cosine of theta is equal to negative 0.86, okay, find theta. You're going to take the inverse cosine of negative 0.86, okay, and that comes out to negative 0.86. If I plug that in my calculator, that comes out to 149.32 degrees, okay, or 0.3. So the answer here is D. And again, remember, just a quick concept, because it's a negative cosine, that puts it out here in the second quadrant. So that's where 149 shows up. Okay, so that's where we're looking at there. Make sure if you're doing your calculator, do that inverse cosine of the negative value and make sure it's in degrees in this case. All right, one more example to go over, and that's our word problem here. A water ski ramp is 5.5 feet tall and 12 feet long, as shown below. Write an inverse trigonometric function that can be used to find theta, then find the measure of theta. Round to the nearest tenth. Okay, so the ramp is 5.5 feet up in the air, and the length of the ramp is 12 feet. Okay, so this is my angle that we're focusing on, that theta right there. So if I label these sides here, that's going to be opposite and hypotenuse. So we know that we're going to set this up with sine, since those are my two known values. So my sine function will be sine of theta is equal to 5.5 over 12. The inverse sine of that is going to tell me my angle measure. So theta is equal to 27.3 degrees. And again, this is what goes in my calculator just like this. Inverse sine of 5.5 divided by 12. That's a bit of a review. You've done that before, actually, but that's just another thing you just want to make sure we're clear on with our inverses. Okay, so here's one you could try on your own. Feel free to do that one. Okay, 8 foot high on the ramp. The length of the ramp is 20 feet. Find that angle that it makes with the water there. All right, that's it for today. Take care, everybody.